Find the total volume of borrowed soil in cubic feet. In this problem, soil is being transported from a borrow site to a fill site, and specific soil parameters are provided. The problem asks to find the total volume of the borrowed material, which we'll designate as VT. We'll also abbreviate the other quantities of the block diagram as shown. In borrow-fill type problems, we usually have separate block diagrams for the borrowed material and for the filled material, since the specified fill material rarely has the exact same properties as the nearby borrow pit. Also, for clarification, a subscript F or B will be added to the variable letters to identify this difference. In this problem, the volumes and weights of solid material is equal. Therefore, we can drop these subscript terms F and B. To find the total volume of borrowed material, we'll start with our 10,000 cubic feet of total fill volume in the fill block diagram. Next, we'll find the weight of the solid material, which equals the weight of solid material in the borrow block diagram. And from there, we can solve for the total volume of borrowed material. We'll also assume the weight of air, WA, equals 0. The total weight of the fill material equals the weight of the water plus the weight of the solid material. Since the water content is defined as the weight of the water divided by the weight of the solid material, we know the weight of the water equals the weight of the solid material times the water content. Making this substitution for the weight of the water into our previous equation, we find the weight of the water equals the weight of the solid material times the quantity 1 plus the water content. Solving for the weight of the solid material equals the total weight of the fill material divided by 1 plus the water content. The dry unit weight of a soil equals the weight of the solid material divided by the total volume. Substituting in our value for the weight of the solid material, solving for the total weight of the fill material, and plugging in the known quantities, the total weight of the fill material equals 1.21 times 10 to the 6 pounds. Now we can solve for the weight of the solid material by plugging in the total weight and water content. The weight of the solid material equals 1.1 times 10 to the 6 pounds. This value is added to the block diagram, and we know it is the same weight of solid material as the weight of solid material in the block diagram for the borrowed material. To find the total volume of the borrowed material, we'll sum the volumes of air, water, and solids. In this equation, the volumes of water and solid material equal the weight divided by the unit weight of each material. And the volume of air is a function of the volume of water and the saturation of the soil. From earlier, we determined the weight of water equals the water content times the weight of solid material. After plugging in the known variables, the weight of water in the borrowed soil equals 1.1 times 10 to the 5th pounds. Next, we'll substitute in the weight of water and solid material, as well as the unit weight of water and specific gravity. And the volumes of water and solid material equal 1,763 cubic feet and 6,602 cubic feet, respectively. The volume of air is equal to the volume of water times 1 minus the saturation as a decimal divided by the saturation as a decimal. After plugging in the appropriate values, the volume of air equals 1,763 cubic feet. This makes the total volume in the borrowed sample of soil equal to 10,128 cubic feet. When reviewing the possible solutions, the answer is D.